Okay, so in this problem, we have one hidden layer, so that's our hidden layer with 3 nodes, and this is the input layer, and in this example we have 2 predictors, fat and salt, so 1 node for each predictor, and then the output layer has the target levels, and there are 2 levels for the target, like and dislike. So this represents like, this represents dislike. So we're going to start with assuming these weights. Okay, so these weights, we will talk more about these weights in SAS. Okay, so let's assume that we have the starting weights as given here in this network. Okay, so here the weights are, okay, so we're going to have the bias in the first row and the weights here going from node 1 to node 3, node 2 to node 3, and so on. So for node 3, the bias is minus 0.3, right? And then the weight going into 3, so from 1 to 3 is 0.05, okay, and 2 to 3 is 0.01. Okay. So the next node in the hidden layer is 4, and the bias for 4 is 0.02. Okay, and the 2 weights are minus 0.01 and 0.03. For node 5, the bias is 0.05 and the weights are 0.05 and minus 0.01. Okay. Now we need to, so these are the inputs coming in to node 1 and 2. So we're going to look at the first observation. So fat is 0.2 and salt is 0.9. So those are the 2 inputs coming in, and they go as output into these 3 nodes. So for node 3, we're getting 2 inputs, one from node 1 and one from node 2, and those 2 inputs are 0.2 and 0.9. So now we need to find the weighted input. Okay, and again the weighted input, like what we discussed last time, it has the appearance of a regression equation. So you have the bias, which is like the intercept. Okay, so the formula then is that, okay, plus the 2 weights. So let's do some product for that. So the 2 weights, okay, and the inputs are weighted by that. The inputs are 0.2 and 0.9. I'm going to absolute reference that so that that can be copied over to node 4 and node 5. Okay, so that is our weighted input coming into node 3. Okay, so for each, so that's our S sub 3 function. Okay, the bias then the weight for the first input, okay, times the value of the input, and then the second one, the weight times the value of the input. So that gives you the output, a weighted input. So that's our weighted input, and then we use the sigmoid function like what we've used in logistic regression for finding the probability. So we apply that 1 over 1 plus e to the power of minus s. We did minus L in logistics. So the same kind of deal here. So this will be 1 over 1 plus exp e to the power of minus. Okay, so that will be the output. So it takes the two inputs coming in, weights it and adds a bias to it, and then converts it into a sigmoid function, and that would be the output going out of that node 3, okay, in the hidden layer. Yeah. All right, so now we copy that. So here are the outputs going out of 3, 0.43, 0.511, then 0.513. Yeah. Now these are the outputs going from 3, 4 and 5 into 6 and 7. Okay. So that's what we have to now use to figure out the output coming out of node 6 and 7. So the output coming from 3, 4 and 5, okay, will become inputs into 6 and 7. So here we can use transpose, okay, transpose being an array function. You have to highlight these 3 cells and then do a transpose of these 3 outputs, close parenthesis, and since this is an array function, you have to go Control Shift and Enter. Okay, so these 3 outputs are now inputs going into node 6 and 7, and the weights, now you have to get the weights. So there are 3 arrows coming in to 6. So we have a bias and the 3 weights. So the bias is minus 0.04 and the 3 weights are minus 0.02, minus 0.03 and minus 0.02. So those are the 3 weights. These are the initial weights, okay, that one, and that one. And similarly for node 7, the bias is minus 0.015 and the weights are 0.01, 0.05 and 0.015. Okay. And these are the weights coming into, so using these 3 arrows coming in, so those are the weights. Now we repeat the computation we did here in the hidden layer. So the bias plus some product of the weights, okay, and with the inputs. The inputs is same for both node 6 and 7, so that should be absolute reference. So this will give us the weighted input. Okay. And the sigmoid function is 1 over 1 plus exp negative of that. So that will be the output coming out of 6. Okay, copy that. Now these outputs need not sum to 1, so we have to find an adjustment such that the probabilities can be found for node 6 and node 7. So that would be, you take that value, divide by the sum of these two, and let's absolute reference that. So that divided by the sum and that divided by the sum will convert these values into probabilities. So now if you sum these two, you'll get 1. Say that plus that will be 1. Okay. Okay, so this is based on just one observation. We have not done anything with the others. Okay. We are only halfway done for the first observation. Now we need to look at the error and use the error to go backwards and revise these weights that we started out with. Okay, which is what we will do next.